All right, in this section, we're going to talk about random variable. Random variable, you can think of it as probability taken to the next level. So we're going to combine the concept of probability and our sampling and all that stuff. So, and this corresponds to the book, section 4.1. 4.1. All right, so random variable is a variable that takes on different values with different probabilities. So variable, I don't know if you guys ever took algebra class, but x is variable, y is variable. One of the property of variable is it's not a fixed number, it changes, depends on the situation. So here we look at things that has different values and its corresponding probabilities. So for example, when it says if you flip a coin 10 times, maybe x could be number of times we get tails, right? Or it's possible I get 0 tails. It's possible I get all 10 tails. It's possible I get 5 different tails. So x is not a fixed number. Depends on who throws it or how it's thrown and all this stuff will have different numbers, right? So this is an example of a random variable. Same for the second one. When you roll a die 10 times, let x be, let's say, number of times, let's say 6 shows up, right? Again, it could be 0, it could be 10, it could be any number between 0 and 10. When we gamble by playing roulette, x could be like the dollar amount that you win. When you play gambling, you can lose $5, you can win $20, you can win $100, whatever. So there could be a different amount that you can win or lose. Okay, maybe add lose. That could be a random variable. I could also say, let's say if you survey 30 people, right, and ask like some sort of yes/no questions. So if I have to add one more, out of 30 people surveyed, it could be number of yes answers, right? It's possible that everyone answers yes, or it's possible that nobody answers yes, and anything in between. So these are all examples of random variable. Every time we talk about random variable, we're going to also talk about probability distribution. They kind of go hand in hand. It is a table or equation or formula that associates a probability with each possible value of x. So from our first example, what's the flipping a coin 10 times example? What's the probability that you get all 10 tails? Or what's the probability you get only 5 tails? There are different probability associated with a particular outcome. So when we talk about random variable, we're going to naturally talk about probability distribution as well. A lot of times you're going to see it as a graph, a table like this. Notice that if you add up all the probabilities, 0.2, 0.30, 0.15, 0.35, you are supposed to get the total. You're supposed to get 1.00, which corresponds to 100%. Because if you add up all the probability, you're supposed to get 1 or 100%. So that's one of the property of a probability distribution. So that's like the next question. It says 2 requirements for probability distribution. The sum of probabilities 1 or 100%. And each probability again stays between 0 and 1. We talked about it before. 0 is same as 0%. 1 is same as 100%. One of the important number they want to calculate from probability distribution table is called expected value. An expected value of a random variable is this part should not be there, sorry about that, just weighted average. Also is mean average, which is same as the mean of all possible values of x. It is what we expect x to be on average. Underline average again. This is basically average value This is what we expected to get, what we expect to get. So for example, our first example, when you throw a coin 10 times, on average, how many tails are you going to see? Sometimes you're going to see more than 5, more than 7, whatever. Sometimes you're going to see probably less than 5. So the question is, on average, how many tails do you expect to see out of 10 times? So that number that we're going to calculate is called the expected value. All right, let's go back here. There's a formula. It's the formula is expected value is x times p of x, and there's a summation. So x is each outcome, the outcomes of the random variable. P of x is corresponding probability, and this symbol is called sigma. Again, it's Greek letter S, but the capital S, which means in math, add up all the numbers. Add up all the numbers. So basically what it says is take x, multiply that by probability of that. You're going to get a bunch of those, and then you add them all up, and that'll give you the expected value. So from this table, if I were to calculate the expected value, let me just do a little side note. Expected value here, what I'll do is I'll take the value of x times its probability, so 0 times 0.2. And then the next one is 1 times 0.30. Keep doing that, I get a bunch of those. Then 3 times 0.35. So far what I did was x times p of x, and I get 4 of these. And the sigma symbol means once you get answered for each one, just add them all up. So it's going to be 0 plus 0.3 plus 0.3 plus 1.05, which is going to give you 1.65. So what it says is on average value is going to be 1.65. However, in reality, we're going to use a calculator. So here we'll use calculator to calculate this. So the calculator function key is going to be use calculate. Then we'll do 1var stats. So this is the one we used before to calculate the mean and all that stuff. Pretty much the same thing. Here we'll use x as our list. So that's it, like L1. And p of x, the probability, is going to be our frequency list. Frequency list. In L2. Then we use the same calculator function key as before. So I can think of this as a frequency table where x is the category and p of x is the frequency. So I'll use that to calculate the expected value. Alright, I'm gonna have you pause and work on number 5 and number 6, and we'll meet back at number 7. I'm gonna give you some hint there. Alright, so here, this is example where we roll 2 dice and it says add together the result. Alright, so like for example, if I rolled 1 and 1, there'll be 2. If I rolled 1 and 2 and 3, there'll be 5, because 2 plus 3 is 5. So these are all possible outcomes of rolling 2 dice together. So it says list all the possible values of x. So smallest number I can think of is 1, 1, which gives you 2. And then I can get 3, and then so on and so forth. And I don't think about the largest number I can get as a sum, which is basically I can get it by 6 and 6, which will give you 12. So my outcome is going to be 2, 3, 4, all the way to 12. So if I were to make this table here x, I'm going to write 2, then I'm going to write 3, I'm going to write 4, 5, start writing here, 6, 7, 8, 9, 10, 11, and 12. Okay, to create the probability distribution. So I got all the x values written down. Then now I have to figure out the corresponding probabilities. So let's see. Let's look at the first one, 2. So I'm thinking in my head, how can I get 2 as a result? Well, only way I can get 2 is just by rolling 1 and 1. That's it. So I have 1 outcome out of the 36 outcomes total. I put 36 on the bottom because when I roll 2 dice, I notice it's 6 by 6. So there are 36 possible outcomes I can get, and out of those, only 1 will give you 2 as an answer. Okay, now I'm going to look at 3. It's like, in what ways can I get 3? So I'm looking at these numbers. I think I can get it by looking at 1, 2, or it could be 2, 1. So those 2. So there'll be 2 and then nothing else, right? So there'll be 2 out of 36 will give you 3 as the sum. I'm going to do one more. Let's see, 4. How can I get 4 as a sum? I can see 1, 3 will give you 4, 2, 2 will give you 4, and then 3, 1 will give you 4. So I see this one, and this. I feel like there's some sort of pattern. So here I can say it's going to be 3 out of 36 outcomes, right? So I'm going to have you fill out the rest of it. And then to calculate the mean and the standard deviation, basically what I'm going to do is I'm going to put this x as L1, and then p of x as L2. Then use, as I mentioned before, calculate 1 var statistics, and x bar will give you the mean, which is the expected value. Okay. And part D, is it unusual to roll a total of 12? So we kind of talked about this unusual usual concept. So this one I'm gonna give you another way to see if something is unusual or not. So say if the probability is less than 0.05, which is 5%, then we can consider something to be unusual. We can consider it to be an unusual event. So magic number we're going to use is 0.05 for now. So this is very similar to outlier concept, because the outlier concept is something that is unusual, something that doesn't happen that often because it's too big or too small. So here, this is like one alternate way to figure out if an event is unusual or not. So here we're going to calculate the probability and see if it's more than 5% or less than 5%. If it's less than 5%, that means probability is pretty small. That means this is an unusual event, right? So, and we're going to use this a lot for the rest of the section, rest of the course. So I want you to kind of remember this part. And we're gonna come back to this concept again in the future. Okay, I'm gonna have you work on number 8, and then we'll meet back at number 9. Alright, we're back at number 9. So it says school club plans to raise funds by throwing a huge outdoor party. The club invests $10,000 and expects to sell $15,000 worth of tickets. So it's like a fundraiser. They're gonna invest $10,000 and they're expecting to get $15,000. That means they're gonna make $5,000. So here I'm gonna see, oh wow, this is $5,000 profit. Okay, that's good. Unfortunately, however, there's a 20% chance that rain on that day, and basically $10,000 is gone, wasted. Wow. So here, if that happens, it's like you lose. So this is you make 5,000 before, but here you can lose 10,000. Wow. Okay, so let's say you're like the planner, right? So you're investing $10,000. There's a chance that you can make $5,000, and there's a chance that you're gonna lose the entire $10,000. hopefully you make money overall, but so here we have to decide if this is a good investment or not by expecting an expected value. So one of the things the expected value does is it could tell if the investment is a good investment or bad investment. So let X be the amount that you make or lose. Basically the concept is if the expected value is positive, that means you're expected to make money on average. However, when the expected value is negative, that means you're losing money, right? So on average, you're expected to lose money, so maybe that's not a good investment. So that's what we're gonna try to calculate here. Okay, so this is our random variable and probability distribution. We have two outcomes. So if you throw this event, either you make $5,000, right? Or you can lose $10,000. Here, I'm gonna write negative 10,000. If I just write 10,000 without the negative sign, it looks like I'm making money, but here I'm losing money, so I'm gonna have to put a negative sign there. They said that there's 20% chance that it's gonna rain, so 20%, I'm gonna put it by the losing $10,000, so 0.20. If there's 20% chance that it's gonna rain that day, that means there's 80% chance it's not gonna rain, right? So 20% rain means I can say it's 80% not rain, because they're complement event of each other. Basically, I'm just subtracting it from 100%. So I'm going to put 0.80. And from here, I'm sure you can finish the question. I just want to get you started on this question. Okay, I think we're done with the worksheet.